So another example can be, let's say we have apple, different fruits, mango, orange, and you can give them labels as 0, 1, 2, and you have to classify a given data set, which one of these labels are there. So basically this task is X, you can have any real number, and Y is anything, like the 0, 1, 2. You have to map this to this. It's known as a hypothesis function. So basically, yeah, till now what we've seen is you have training data, and according to the data, you get an algorithm. We'll look at what algorithms are there in the coming classes. There's linear regression, logistic regression, you have SVM, neural network, random forest. I'm just throwing these names out. Uh, if you're curious, you can Google it, but we'll go through it anyway. And according to the algorithm, we get a hypothesis function. This is basically this function we've looked before. So what we pass through the hypothesis function is some unseen data, seen data. After this algorithm, the model has, basically seen through all the labeled data. Like it knows that if you have, point 1, point 2, point 3 of something, then you'll get an orange. At this point, the model knows that. And now we are just testing on some unseen data, whether we're able to get the same desirable output or not. The prediction basically. So this is the Y prediction. And this hypothesis has different parameters on itself by itself. We look at some, how you represent the parameters. It's nothing too fancy. So if you have a straight line y is equal to mx plus b, these are the parameters in this case. The m and the b are the unknown. Any questions? Are you all with me? All right, we'll be coming back to this in future lectures as well. But I hope you followed this. It's pretty like important and basic, which it's good to have at early stage. I came to know of this fairly uh, later on. So it's good to have this. So yeah, the next learning paradigm we'll be talking about is unsupervised learning. In the name itself, you see that you're trying to learn something without human supervision. You're not trying to label something. You're not trying to tell whether this is a dog or a cat or an apple or a mango. So you're trying to learn without no supervision, and that means there's no labeled data. The algorithm has to find the pattern on its own from the structure of the data. The data can be present in form of groups, clusters, similar point. Basically, these are the same. Only the x values are known and the y values are not known and doesn't require human supervision. Is labeled data the same as training data? Um, so there are two ways of writing data. One is labeled and unlabeled. In labeled, what we have is let me show this. So let's say you have passenger ID. You have the sex, age, from embarkment. These are kind of never mind the spelling. These are kind of the features you have, and you have values within them. Just randomly, let's take 0 to wait, no, this is M 21 C something, and this is the Y label. This is the label actually, uh, Aditya. Yeah, I'll go through it anyway. So this label will be whether they survived or not. So let's say they didn't survive, unfortunately, and you have another type of data over here, and they survived. So this is so you have a label for every example over here. That's labeled data. But whereas in unlabeled data, you have all this, the X values, but you don't have the label. You don't know whether they survived or not. So in that case, what you expect the algorithm to do is to find the pattern in the structure of the data. The algorithm looks at clusters and tries to tries to assign a label to each cluster, whether they survived or they did not survive. It doesn't require human supervision. Is that clear, Aditya? Okay. One example of a very common and I think the most simple example of an unsupervised algorithm is k-means clustering.